box. Great. Thanks for letting me know. So let us start this session. Yeah. So previously we have started with discussing about combinational circuits, and we have in detail discussed about half adder, next full adder, and coming to ripple carry adder, and we have seen what is the disadvantage with we are having with the case of our ripple carry adder, and we have moved to our carry look ahead adder. We have discussed, right, and that is what our discussion was, right. Now in this particular session, let's continue our discussion about adders itself, and let's try to discuss something known as BCD adder. Right now, we are going to discuss this adders, and today we will complete this BCD adder, and tomorrow we will be completing our subtractor related circuits, and if adder comes subtractor related circuits, so that we will be completing all the adders and subtractor related circuits. Right now, next plan is we are going to discuss something known as multiplier, and after that we will be completing multiplier, comparator, and code converters. Let me first of all give you an idea of what exactly we are going to discuss in our further sessions. So you will also have some clarity of what are we discussing, right? One second, let me share my screen. Hope my screen is visible, right? Please let me know in the chat box. Is my screen visible? Yeah. So coming to uh, the things which we are going to discuss in our further sessions, let me write it down quickly so that you will have an idea. So in this session, we are going to discuss something known as BCD adder, and next we are going to discuss about adder cum subtractor circuits. In tomorrow's session, after completing subtractor circuits, we are going to discuss adder cum subtractor, and also we have something known as comparators, and this is what we are going to discuss in the next upcoming sessions, right? So after this we are going to start with something known as very important topic, mux and demux, and we are going to discuss so many problems related to multiplexer and demultiplexer. Okay, so we are going to have so many numericals related to multiplexer and demultiplexer. After this we are going to start our discussion regarding encoder and decoder, and after that we are going to discuss about code converters. Okay, so in terms, in your interview perspective, what is that particular topic you need to focus upon, and what topic you need to practice a lot is, I suggest multiplexer and demultiplexer related problems as well as decoder related problems. Anyways, I will also show you like what kind of problems you will be facing in your interviews, and not that you can skip this adders and subtractors or comparators. You need to have an idea of everything. But in most of the interviews, in the written test, especially wherever you go, in multiplexers and decoders related problems, you will be encountering the most. So that's the reason we will be having more problem discussions on multiplexer and decoder, and related to demux also we are going to have some kind of problems, right? So this is the agenda for upcoming sessions, and I will be little bit irregular in the sessions because I'm having some project related works, so I'm busy with that particular thing. So yeah, that is our agenda. Okay. So with this, we will start with this particular session now. So we will start with something known as BCD adder. So basically, we have already discussed about BCD. What do I mean by BCD? BCD is nothing but binary coded decimal. And what is this BCD adder is going to do? Let us try to understand. Let's say if I'm going to have a circuit like this. Now, in our BCD adder, I'm going to have 4-bit inputs. Let's say one is A, which is of 4 bits, and another is B, which is of also 4 bits. So A is of 4 bits and B is of 4 bits, and I'm going to also have something known as C, initial carry, and output sum, which is of 4 bits, and C out, which is of 1 bit. Okay. So this is nothing but my BCD adder block diagram, which I'm going to have. Now, what is this BCD addition? So in our, when we were discussing about number systems, we have already discussed about our BCD addition. So let us once recap that particular thing. So let's say if my A is equal to 1010, which is an invalid BCD number, we should consider a valid BCD number. Let's say it is equal to 8 and B is equal to 1. So if I'm going to add this, I'm going to get obviously 9, 1, 0, 0, 1. Okay. Now let's say if I'm going to add 1, 0, 0, 0, 0, 1, 0, which is nothing but 8 plus 2, which is nothing but 10, 1, 0, 1, 0. Now, this is invalid, right? Now, if you're going to get any invalid BCD number, you're going to just add plus 6 to make it valid. 0, 1, 1, 0, which is nothing but 0, 1, 1, 0 is 1, 1, 1, 0 is 1, 1, 1, 0, 1. So, this is the valid BCD number which I'm going to have. So, this is what BCD adder should also do. If you are going to get any invalid sum, it should add plus 6 to make it valid. That is what the BCD adder should also do. And over here, we have some initial carry C in also and output carry C out. Okay, this is what our BCD adder is going to have. Now, if I'm going to have A is of 4 bits and B is of 4 bits and C in of 1 bit, what is the maximum sum I'm going to get? If A is of 4 bits, B is of 4 bits and C in of 1 bit, what is the maximum sum I'm going to get over here? Anyone wants to answer? Simple question. If my A is equal to 4 bits, B is equal to 4 bits, and C is equal to 1 bit, what is the maximum sum I'm going to get over here? What is the value of sum which I'm going to get over? Are you sure? Yes. So what is the maximum sum I'm going to get over here? Are you sure? 9 is sure? Okay. So let's say if the user who is providing value of A as all ones and B is all ones, he can provide like this? No, he should not provide this all ones and all ones. So the maximum value of A the user can provide is 9 and the value of B can be equal to 9. This is the maximum value the user should provide. So he should not provide this all ones and all ones because this is not a BCD number, right? So 1001 and 1001 if he is going to provide and C is equal to 1, then 9 plus 9 is 18 plus 1 is 19. So the maximum value of my sum will be equal to 19. Okay. And over here, C out will be equal to what? Is it clear, guys? What is the maximum sum over here? So if the user is providing, I'm talking about valid BCD numbers. Okay. If he's providing invalid BCD numbers, it's another case. But we are assuming that the user is providing only valid BCD numbers. That is 9 and 9 and our initial carry C is equal to 1. So 9 plus 9 is 18 plus 1, which is nothing but maximum value is 19. So some maximum value is equal to 19. Okay. Is it clear? Now, so we need to let me write it down. So this is my C out. Let's say this is my C out, and let's say this is my S3, S2, S1, and S0, which is nothing but my sum, which is the output of this particular circuit, right? Now, uh, from 0 to 9, we don't have any particular problem because those are valid output. So that means what I mean is C out can be equal to 0 and S3 can be equal to 1 and remaining can be equal to 1. This is up to here, it is valid. From 0 to all zeros to 9, these are my valid numbers, right? Now, from 10 to 19, these are all invalid. So what do I mean? So 10 is nothing but 1 0, 1 0, 1 0, 1 1, 1 1, 0 0, and 1 1, 0 1, 8 plus 4, 12 plus 1, 13, 14, and 15. And I cannot have 1, 1, 2, 3, 4, 16, 17, and 18, and 19. So these are all the invalid outputs which should be discarded by adding plus 6. Okay, so this should be resolved by adding plus 6. This is what our requirement is, right? So this is what we have also seen in our addition. If we are going to get some value greater than 9, we need to add plus 6 to make it valid. So that is what our circuit should also perform. right? Now, how we are going to perform? We are going to analyze here. Okay. So we are not going to consider this valid case. This we are going to skip it. Here we don't have any particular problem with this particular valid case. The problem arises from here. Okay. Now, if you carefully observe over here, this is my C out, and this is S3, this is S2, this is S1, and this is S0. So let us take a variable or a particular signal which is known as invalid. So this will be equal to 1 whenever your C out is equal to 1. We can see, right? Whenever our C out is equal to 1, these are all our invalid cases. C out. And here you can see C out is equal to 0. So that we are going to give OR option over here. C out can be equal to 1. It is an invalid. Or C out can also be equal to 0 in these cases. Okay. So I've considered the first case where C out is equal to 1. So that I'm written over here. C out is equal to 1 plus. Now here I should see. Now in this all cases, you can see S3 is equal to 1. So that what I'm going to do, S3 into. Now you can see in these two cases, S2 is equal to 0 and S1 is equal to 1. 0, 1, 0, 1. Okay. So that, and what is happening over here? S2 is equal to 1 and S1 is equal to 0. Okay. And in this particular case, both are equal to 1. So can I write simply S2 plus S1? Yes. So S3 into S2 plus S1. That means if S2 can be 1 at one time and S1 can be 1, or both can be equal to 1. In these two cases, my invalid will be equal to 1. And S3 is always 1. That's it. So by seeing this particular table, I have written this particular equation. How I have written? Let me explain you one more time. One scenario is C out should be equal to 1. C out is definitely equal to 1 to make your to consider your output to be an invalid, or C out can be equal to 0. That's the reason I have written OR. Okay. In this case, in the second term, C out is equal to 0. Now, what is happening? In this case, you can see S3 is always 1 and S2 or S1 or both are equal to 1. That's the reason I've written S2 plus S1. That's it. This is my invalid equation which I'm going to have. So you can substitute over here. If your output is 1 all zeros, invalid will become 1. Or else if your output is 1 1 0 0, here also your invalid will become 1. So if any one of the value is given, then this particular invalid signal will be equal to 1. Is it clear for everyone how I have framed this particular equation? Is it clear for everyone? Any queries over here? Any queries over here? Okay, fine. Now, coming to the circuit, like how the circuit is going to look like, let's have a look into it. So what I'm going to have a particular ripple carry adder for this, or a 4-bit adder. Now this 4-bit adder is going to consider your inputs B3, B2, B1 and B0. And it is going to consider A3, A2, A1 and A0. And the initial carry seen. And from here, I'm going to get, let's say S3, S0 dash and S1 dash and S2 dash and S3 dash. These are the sum, intermediate sum I'm going to get. Okay. Now this I'm going to pass it to one more 4-bit triple carry adder. This is RCA and this is one more RCA where I'm going to provide S0, S1 dash, S2 dash and S3 dash. Now, whenever let's take one signal which is known as invalid. This invalid will become 1 whenever this equation got satisfied. So this is my C out. This I'm going to consider C out or with S3 into S2 plus S1. S2 plus S1. S3 into S2 plus S1. And this is my invalid. So invalid will become 1 whenever I have got this particular equation. Now this particular thing which we are going to give it to, this is my B3, B2, B1, B0 and this is A3, A2, A1, A0. Now, what are we doing if our sum is equal to, let's say, 1010, which is invalid, right? We are adding with the second input 0110. You can see in 0110, the middle two bits are equal to 1. So that's the reason whenever your invalid is equal to 1, middle two bits should be equal to 1. So that is the reason I'm going to give the connection to this invalid to B2 and B1 and remaining bits connected to 0. So that whenever we are going to get any invalid sum, my invalid signal will become 1 and I'm going to add this intermediate sum with 0110 and I'm going to get the corrected sum S3, S2, S1 and S0. This is my final sum and this is my Cout. So this is how I'm going to design a simple BCD adder by using this kind of circuitry. Okay. Yes. Any doubts or any queries in this particular circuit? Please look into it and let me know if there is any query. Is the circuit clear? The BCD adder circuit? Hello. Am I audible, right? Great. Okay. So that's about this BCD adder. And in our next session, we are going to discuss about adder cum subtractor circuits, and we are going to discuss the comparators and little. We have few combinational circuits which are left out that we are going to discuss. And next, we are going to discuss about something known as multiplexes. Okay. So in multiplexes, we are going to discuss so many mux related problems. We are going to have a discussion. Okay. Yes. So that's about this particular session. If you have any doubts or any other queries you wanted to discuss, you can stay and discuss with me, or else we can wrap up the session. Okay. Thank you.